Hello, this is AP Chemistry, Chapter 5, Section 7. Today we're going to go over gases in stoichiometry. So in a reaction involving gaseous reactants or products, we often specify the quantity of gas in terms of volume rather than mass, like we're used to in stoichiometry. As we have seen, stoichiometry involves relationships between amounts and moles. So remember that the foundation of stoichiometry is going to be moles of A to moles of B. So for stoichiometric calculations involving gases, we can use the ideal gas law, Pivnert, to determine the amount of moles, or N, from the volume, or to determine the volume from the amount in moles. Here is the value of the moles. So this is how we first learned to convert from grams to moles and moles to atoms. So remember that this is the beginning of stoichiometry. So being able to convert between grams and moles is the basis. They could ask us for atoms, but they practically never do. So we're going to be multiplying or dividing by the molar mass to change between grams and moles. And here is our value of stoichiometry. So this is the one that we've been working with, where we're given grams of a substance A, and we're asked usually to find grams of the second substance B. So A could be a reactant, it could be a product, and then same. You're converting it just from one part of an equation to another part of that equation. Okay, so you can see this is gas stoichiometry, and it still boils down to moles of A to moles of B. And so we can be given grams, just like we were in the regular stoichiometry problems, or we can be given pressure, volume, temperature, and use that to calculate the moles. And then at the end, we could be looking for grams. So we could be using the molar mass over here to find grams of B, or we could be given pressure, volume, temperature, and we could use moles to change to pressure, volume, or temperature of that substance. Let's do some examples. Example 512 from page 221 says methanol can be synthesized by the reaction. So see, we have two parts coming together and make one part. What volume in liters? So we're looking for V at the end of hydrogen gas. So we're looking for the volume of hydrogen gas at a temperature of 355 Kelvin and a pressure of 738 millimeters of mercury is needed to synthesize 35.7 grams of methanol. So we have a lot going on. Let's break it down into our given. So we're given the grams of methanol. So that's going to take us back to right here at the beginning. So we're going to use molar mass to change it from grams to moles. We are also given the temperature of 355 Kelvin and the pressure in millimeters of mercury. I've gone ahead and changed it to atmospheres for you. So we just divide by 760 and we get 0.971 atmospheres. Make sure you know how to convert the units of pressure there. And then what they're asking us for, since we are collecting a gas, hydrogen gas, we want to find the volume in liters. So at the end, we're going to end up here with V, with volume. Okay, and we're going to use Pivnert to calculate that. All right, so here's our plan. We're going to go from grams of A to moles of A by dividing by the molar mass, and then moles of A to moles of B using the mole ratio, and lastly, Pivnert to change from moles to volume. So let's get started. We have 35.7 grams of CH3OH over 1. We need moles of this methanol. So we have to convert it to moles. Moles go up top. Get rid of that. The bottom has to be grams so that they cancel. Okay, grams of methanol per mole of methanol. That's just the molar mass. CH3OH. Okay, and 1 mole is, we need to add up my 12 for the carbon, the 4 hydrogens, and the oxygen. And if we add those all up, we get 32.04. Okay, 32.04. Now we're at moles of our methanol. So now I want moles of CH3OH on the bottom, and what we're looking for, which is hydrogen gas up top. And we need the mole ratio here from the balanced equation. It is 2 to 1. So 2 hydrogens for every 1 methanol. And last, whoops, sorry, we're going to actually stop there because we can't write a conversion factor to go from moles to volume. We have to actually plug it into Pivnert. So let's calculate how many moles. We're going to multiply across the top, so 35.7 times 2, and divide that by 32.04, and we will get 1.1142 moles of hydrogen gas. Okay, but what volume is that? So PV equals nRT. They have given us the pressure, the temperature, and we just calculated moles. So to find the volume, we're just going to take nRT divided by P. So all I did was divided by P on both sides. These cancel, and volume equals this guy. So let's plug it all in. How many moles times our R, 0.08206 liters, atmospheres over moles times Kelvin. The temperature was 355 Kelvin, all over my pressure in atmospheres, because this R value, I should have written it out, liters, atmospheres over moles. Kelvin is my unit, so Kelvins cancel, moles cancel, and then atmosphere needs to cancel here. So we have 0.971 atmospheres. So that is going to cancel, and I'm left with liters. And then if we plug this into our calculator, we should get 66.9 liters. So a good amount of hydrogen gas being produced, right? For practice, right underneath it, I want you guys to try the for practice problem on your own. And the reaction shown here, we have 4.58 liters. So we're starting with liters this time. So we're going to go back and start here with volume, and we're going to use Pivnert to change it to moles. We have a pressure here of 755 millimeters of mercury. Remember to change that to atmospheres. Temperature of 308, and they want to know how many grams. So this is the exact opposite of what we just did. We're going to use Pivnert in the beginning to find moles, and then the mole ratio. And then at the end, we're going to change it from moles of B to grams of B. All right. Okay, let's do this problem. So we have, always start by writing out your given, and I'm not going to use, I am going to use the temperature and the pressure here at the beginning, and the volume. So we have, what I'm looking for at the end is my grams of silver oxide. So what we're starting with is going to be the amount of oxygen that we have being formed. So we need to figure out how much of this decomposed if we know how much oxygen was produced. Okay, so we have, we need moles over here so we can convert. So I'm going to solve for N. N equals PV over RT. I just divided both sides by RT, so these cancel. And I solved for N. Then I have my pressure of 0.98 atmospheres times my volume, which was 4.58 liters, divided by 0.08206 liters atmospheres over moles Kelvin, times my temperature of 308 Kelvin. And so liters are going to cancel, atmospheres cancel, this Kelvin cancels, and I have 1 over moles, which is just moles of oxygen. So we have to plug this in, and I will get 0.98 times 4.58 divided by 0.08206. I'm going to hit equals, and then I'm going to divide by 308. All right, so I have over here, I'm going to write it at the top because I didn't leave myself room, 0.17759 moles of oxygen. So that's what I'm going to start with in my stoichiometry problem. I'm not rounding for sig figs yet. I'll do that at the end of my calculations because the more you round during the process, the less accurate your answer actually becomes. So I have moles of oxygen, and I can change that to moles of my silver oxide, the one we're trying to find. And the ratio is 2 to 1. So 1 oxygen is given off for every 2 silver oxides that decomposed. And the question asked me for grams. So if I divide by moles of Ag2O, grams of Ag2O, this is the molar mass, I will get grams of silver oxide produced. Okay, and we can easily go to the periodic table and look up the molar mass of silver. I'm going to do what you should not do. I have 231.74, 231.74, 231.74, and then we need to calculate this. Clear. So 0.17759 times 2 times 231.74 equals 82.3. And how many sig figs did we start with for all of these? It looks like I have 3 sig figs in all of my givens. So I want 3 sig figs, so we're going to leave it right there. And we can always check our answers to the 4 practice in the back of your textbook. So just so you know, the answers are there. All right, so example 513, how many grams of water form when 1.24 liters of hydrogen gas at STP? This STP is actually a big red flag that makes our life easier. Completely reacts with oxygen. Okay, so I'm going to start with this many liters of hydrogen. 1.24 liters of hydrogen over 1. Because it's at STP, remember that we have 22.4 liters in 1 mole, so I can easily find how many moles just by using this instead of Pivnert. Okay, so this makes my life a little easier. So it's going to be 1.24 divided by 22.4. So I have 0.055357 moles of hydrogen. And from there, I'm going to go from moles of hydrogen to, what were we looking for? Grams of water. So I need to go from moles of hydrogen to moles of water. Five, 7 moles of hydrogen over 1. Moles of H2 go on the bottom. Moles of H2O go up top, and this is a 2 to 2, which cancels out 1 to 1 ratio, and it says how many grams of water. So in 1 mole of water, this is the molar mass. How many grams are there? If you said 18.02, you are correct. Okay, and so we're going to multiply across the top, and I should get 0.998 grams of hydrogen for this problem. Okay, do the 4 practice 513, please, and let's see if you get the answer correct. All right, let's solve the problem. So I am starting with grams of water, and I want to end up with liters of oxygen. And we're at STP again. So good news, I can go from grams to moles by dividing by the molar mass, moles of A to moles of B by multiplying by the mole ratio. And then at the end, I'm going to use that 22.4 liters to change it from moles to volume. Right, let's get started. Over 1, change that to moles, 18.02 grams in 1 mole of water. So grams of water have canceled. Mole of H2O on the bottom, and this time we are talking about oxygen. So we want moles of O2 on the top, and this is a 2-to-1 ratio. Okay, and let's just go ahead and include that last part in here since we can. It's not a PivNert problem. 1 mole of oxygen only at STP. So because this says STP, I know the molar volume is 22.4 liters. Okay, and I can plug that into my calculator. So I have 10.5 divided by 18.02 equals, okay, and then we're going to multiply by 22.4 equals, and lastly divide by 2. And we get 6.53 liters of oxygen gas. All right, that's it for section 7. Have a wonderful day.